This videotape will instruct you on how to set up and straight turn a cylindrical workpiece between centers. After viewing this videotape, you should be able to write down the safety procedures required in every machine shop, write down the steps needed in setting up the workpiece before turning between centers, and write down the procedure for turning between centers. When you are in the shop, you have to take some precautions that will protect you and the people around you. These include wearing your safety glasses, removing all jewelry, rolling up your sleeves, and checking to make sure your clothes fit tight enough so they won't get caught in the machinery. There are two methods you can use to ensure the proper alignment of the headstock and tailstock for turning between centers: the visual method for rough alignments, and the test bar and dial indicator method for precise alignments. For the rough alignment or visual method, look for the marks or calibrations stamped into the base and top half of the tailstock. These are called cricket marks. For zero taper, the zero calibration or the mark should be in a straight line. To make a further visual check, insert centers into both the headstock spindle and the tailstock spindle. Slide the tailstock toward the headstock so that the tips are almost touching each other. If the tips of the two centers are in a straight line when viewed from directly above, then the headstock and tailstock are roughly aligned. This type of alignment is adequate for performing non-precision operations between centers. If the tips of the centers are not perfectly aligned, you can make the necessary adjustment by first loosening the tailstock clamp and then adjusting the offset screws. For the precise method, you place a test bar between the centers and set up a dial indicator on the crossfeed. Use the crossfeed to bring the pointer against the test bar at the headstock end. Move it in until the needle has moved halfway around the face of the dial. Set the zero reading over the needle. Set the crossfeed micrometer collar to the zero reading. Use the crossfeed to back the dial indicator away from the test bar. Now position the pointer on the tailstock end of the test bar. Move the crossfeed in and bring the crossfeed dial to the zero position. If you do not get a zero reading on the dial indicator, loosen the tailstock clamp and adjust the offset screws to move the indicator needle to the zero position. Move the indicator back to the headstock end and check for a zero reading on both the indicator dial and the crossfeed micrometer collar. This method is very accurate for removing taper from centers or when very little material is to be removed from the diameter of a workpiece. With the taper removed, you are now ready for the second step, mounting the chuck to hold the workpiece. Using a cradle block to protect your fingers and the ways, lock a 3-jaw universal chuck on the spindle nose. Place the rough sawed workpiece in the chuck and tighten the jaws securely with the T-wrench. Don't over-tighten, or you may spring the scroll out of alignment. Set up the tool bit for facing the workpiece. Knowing the diameter of the workpiece and the cutting foot speed of low-carbon steel, You can calculate the spindle RPM for finishing using the formula RPM equals 4 times 100 divided by 1.5, or 266 RPMs. Now set the RPM and the feed rates. Face one end of the workpiece. After you have faced one end, you are ready for the next step, center drilling. Place a drill chuck in the tailstock spindle. Check to see that the tang of the drill chuck fits securely in the slot of the tailstock spindle. You need to select the appropriate combination drill and countersink for the size of the workpiece. This tool is more commonly called a center drill. The size of the center drill you use depends on the diameter of the workpiece you are going to support between centers. Check the blueprint for the center hole diameter. Consult your machinery's handbook for the chart showing what size center drill to use. In this case, the workpiece is 1.5 inches in diameter, so use a number 4 center drill. Secure the center drill in the drill chuck and tighten with a chuck key. Leave about 1/2 inch of the drill extending out of the chuck. Using the same formula that was used to determine finishing speed, you can calculate drilling RPM. 4 times the cutting foot speed of low-carbon steel divided by the diameter of the drill, which is 4 times 100 divided by 1/4, equals 1600 RPMs. Reset the RPMs. Move the tailstock to within 1 inch of the workpiece and lock it in place. Place a drop of oil on the center drill. With the workpiece rotating at 1600 RPMs, slowly turn the tailstock hand wheel to force the center drill into the workpiece. According to the blueprint, the diameter of the center hole in the workpiece should be 1/4 inch. When it appears that you have drilled to this diameter, back the center drill away from the workpiece. Stop the spindle. And check the diameter with a scale. If you make the center hole too shallow, you will provide very little support for the workpiece between the centers. If you make the center hole too deep, the tapers of the lathe center and the center hole in the workpiece cannot make good contact with each other. If the diameter of the center hole is not 1/4 inch, start the machine again and drill the hole to the proper diameter. If you drill too deep and the diameter of the hole is too large, face off the end of the workpiece to reduce the diameter to the proper dimension. Now, polish the center hole to provide a snug fit for the lathe center in the center hole. Use a piece of fine, number 400 polishing cloth folded like this. Or use a tapered dowel rod sharpened to a 60-degree angle with the polishing cloth wrapped around the tip. Break the sharp corners with a smooth file. One end of the workpiece is now finished. Remove the piece from the 3-jaw chuck and reverse it so that the same operations can be performed on the other end. Lock the piece in the 3-jaw chuck. Face the other end to length. And center drill it to a 1/4 inch diameter center hole. Break the sharp corner with a file. You have now completed the setup phase and are ready to turn between centers. Remove the 3-jaw chuck and mount a drive plate on the spindle nose. Place a sleeve into the spindle and insert a solid center into the sleeve. This center will support the headstock end of the work for turning between centers. Remove the drill chuck from the tailstock by turning the hand wheel to move the spindle into the tailstock. Most tailstocks are designed to kick out the center when the spindle is backed all the way in. Run the spindle a little way out again and insert a live center into the tailstock. This center is made with ball bearings to be able to rotate with the workpiece. The lathe dog, when attached to the workpiece and fitted into the drive plate, drives the workpiece for the turning operation. Select a lathe dog that will fit the diameter of the workpiece. Mount the dog on the end of the workpiece by tightening the screw. With one hand, position the workpiece at the headstock so the center hole fits the lathe center and the tail of the lathe dog fits into one of the slots in the drive plate. With the other hand, move the tailstock so the live center fits into the center hole of the workpiece. Turn the tailstock hand wheel to extend the tailstock spindle approximately 3 inches. This secures the center against the workpiece. Lock the tailstock in place and check to see that the workpiece and the lathe dog are aligned and secure. Lock the tailstock spindle. Set the compound to 30 degrees off the perpendicular. Set up the right-hand finishing tool in a left-hand tool holder. The left-hand tool holder provides the best clearance for this operation. Keep both the tool bit and the tool holder overhang to a minimum. Tighten them in place. You are now ready to set the spindle RPM for finishing. Remember, spindle RPM is equal to 4 times the cutting foot speed for low-carbon steel divided by the diameter of the workpiece. In this case, RPMs equals 4 times 100 divided by 1.5, or 266. Set the spindle RPM at 266. To end up with a good finish, you need to select a finishing feed of 5/1000 of an inch per revolution. This feed rate moves the tool so that the cuts will overlap each other and remove the ridges. Start the machine and use the cross feed and carriage hand wheels to move the tool to the tailstock end of the work. Advance the tool to make contact with the circumference of the workpiece. This is called picking up the cut for straight turning. To end up with a finished diameter of 1.350 inches, you must do some planning and calculations. When you set the depth of cut at 50/1000 of an inch, you are removing 2 times 50/1000 of an inch from the diameter. You will therefore need one cut at a depth of 50/1000 of an inch and a final cut at 25/1000 of an inch. As you can see, 2 times 50/1000 equals 100/1000 plus 2 times 25/1000 equals 50/1000 for a total of 150/1000 of an inch from the diameter. After picking up the cut, advance the tool bit for a depth of 50/1000. Engage the longitudinal feed. Complete the cut up to the lathe dog. Move the tool back to the tailstock end of the workpiece. Before making the final cut, stop the machine and check the diameter with your micrometer. Move the cross feed dial to remove enough material to give the desired diameter. Complete your final cut to the finished diameter. Stop the machine. Check the diameter. As you see, This diameter measures 1.350 inches. To finish the turning between centers, reverse the position of the workpiece. First, loosen the lathe dog screw. Then, back off the tailstock spindle so that the workpiece may be easily removed. Mount the lathe dog on the finished end of the workpiece. Place a shim between the lathe dog screw and the workpiece to prevent marring the finished surface. Tighten the lathe dog screw. Fit the lathe dog into the slot of the drive plate and properly secure the work between centers. Repeat the procedure you used on the other end to complete the work to a 1.350-inch diameter. Let's review the major steps in turning a workpiece between centers. First, align the tailstock with the headstock by the visual or the precise method. Next, you face one end of the workpiece and center drill it. Reverse the workpiece to face the other end and center drill it. By holding the workpiece between centers and driving it by means of a lathe dog and drive plate, turn the work to the proper diameter. You have now seen how to turn a workpiece between centers.